Locus part 3. Before I start this problem, I have to mention this property about locus. Suppose we have a point A. Suppose we have triangle ABC, right angled at A. And suppose we have B is fixed, C is fixed, A is variable. A varies in a way it is always right. Where is the location of point A? What is the set of points A? When we have right triangle, we always have median, right, relative to hypotenuse equal half of its measure. Suppose M midpoint of BC. So MA will be equal also MB equal MC because MA equal half BC. This means if we put a compass here at M, since B, A, and C are equidistant from M, so we are going to have a circle. We are going to have a circle with center M, right? And this circle passes through A, B, and C at the same time. This circle passes through A, B, and C at the same time because MB equal MA equal MC. This means A cannot be 90 except if A is on a circle with diameter BC fixed, M midpoint of BC, so it's also fixed, and the radius is half BC, which is equal to MB or equal to MC, which is a constant radius. This means A could be anywhere on this circle, right? And if A anywhere on the circle, the triangle ABC will be always right at A. For sure excluding the points B and C. Because if A on B or A on C, this means we don't have triangle, right? We will have a straight line. So we don't mention that. We just say it moves on a circle. A moves on a circle with diameter BC, radius half the measure, half the length of BC, and midpoint is the center. The midpoint of BC will be the center. Okay, this is very important thing. So let us see over here what do we have. We have ABCD is a rhombus. ABCD is a rhombus. A, B, C, D is a rhombus, right? AB is fixed. AB is fixed. CD varies, but in a way, CD varies, but in a way, it remains a rhombus. This means this side equal to that side, equal to that side, and equal to that side, right? And how to find the locus of the point of intersection of the diagonals of the diagonals as points C and D varies. They vary in a way, okay? They move in a way. All the sides are equal because it's given a rhombus. We need to find the, let's say M, the point of intersection of the diagonals. We have 90 over here, right? Over here, over here, and over here. Why this is 90? Because we need to find the locus of this point. This is 90 because the diagonals of rhombus are perpendicular to each other. They are perpendicular to each other. We can do it as two parts. First, we prove it a rhombus, then we take it as a rhombus. In both cases, we should know that this 90 here, we don't take this or this or this. Why? Because we measure this 90 according to AD. A is fixed, D is variable. And here we measure, we can't find the locus of M if C and D both varies. Here C varies, B is constant, B is fixed, sorry. So we take angle A and B. If angle A and B equal 90, right? This means where's the set of points M? It's exactly like this one, right? So it varies on a circle with diameter AB. It varies on a circle with diameter AB. We can we can prove that by different ways. But what is the locus of point M? The locus of point M will be the circle with diameter AB, with center midpoint of AB, with radius half the measure of AB. This is important too. Okay, we still have some time, so let's do this one. Given rectangle ABCD, suppose we have a rectangle ABCD. Okay, suppose we have this rectangle A, B, C, and D. Okay, first, what is the set of points equidistant from segments AB and CD? What is the set of points equidistant from the segments AB and CD? What about AB and CD? AB and CD are opposite sides of a rectangle, right? So are they parallel? Yes, they are parallel. So first thing I have to know that AB is parallel to CD, right? AB is parallel to CD. What else? So what will be the locus? What will be the locus or the set of points which is equidistant from two parallel lines? Simply, any point which is equidistant from these two straight lines, any point which is equidistant from these two parallel lines will be what? Will be, right? Will be on this line, which is parallel to AB and CD, and will be at the same distance from this distance here is equal to this distance over here, right? So this means any point on this line will be equidistant from AB and CD. So this line is a straight line which is parallel to AB and parallel to CD, midway between them, halfway between AB and CD. And this is very important. What else? What is the set of points equidistant from points A and B? What is the set of points equidistant from points A and B? This is very simple. We did that as an activity before. You can check video part 2. Any point equidistant from the segment AB, let's say it's the midpoint of AB, right? Let's say it's the midpoint of AB. And someone will say, no, M, which is equidistant from A and B, it's not only the midpoint, it could be somewhere here, or somewhere here, or somewhere here. In a way, always we have MA equal MB. All these points, if we join them, we get what? We get the perpendicular bisector of segment AB. So in this case, the set of points M, since MA is equidistant from A, since point M is equidistant from A and B, since MA equal MB, always MA, wherever we put the point M, it should be equidistant. Directly we can guess that the set of points M is the perpendicular bisector of segment AB. Okay, I still have some time also. Let's see what is the set of points equidistant from the points A, B, C, and D. What is the set of points equidistant from these 4 points A, B, C, and D? First, what is the set of points equidistant from A and B? I said it's the perpendicular bisector of AB. What is the set of points equidistant from points B and C? It is the perpendicular bisector of the segment BC. And what is the point that is equidistant from C and D? It is the perpendicular bisector of segment CD. And from A and D, it is the perpendicular bisector of AD. So these two axes of symmetries of the rectangle and axes of symmetries are straight lines that passes through, that perpendicular to the opposite sides, right? So that passes through the meeting point of diagonals of rectangle. This means the meeting point of diagonals of rectangle